All right, let's get into it. Today we're diving deep into the world of manufacturing to see how AI is completely shaking up one of the most critical and honestly one of the most difficult industrial processes out there, the art and science of welding aluminum. You know, this quote right here, it just nails the entire problem. We're talking about structural integrity. This is the stuff that keeps our cars, our airplanes, our buildings from literally falling apart. So the stakes, they couldn't be higher. And the old way of doing things is basically just spot checking a tiny fraction of the work. That's where AI comes in to change the whole game. So why all the focus on aluminum? Well, in industries like automotive and aerospace, every single gram counts. You need components that are super strong, totally flawless, but also incredibly lightweight. The catch is, aluminum is notoriously tricky to weld perfectly. The process itself is so complex, so harsh, that defects are almost a given. And those tiny flaws can lead to some really big problems. And this slide really shows you the massive shift in thinking. On the left, you got the old way. It's reactive. You finish the weld, and then someone comes along to manually check a few random spots. But on the right, that's the AI approach. It's proactive. It's intelligent. It's monitoring every single weld in real time as it's actually happening. It's a total transformation. To make that leap, you've got to give the machines senses. And I'm not talking about just normal senses, we're talking about giving them superhuman senses. These are systems that don't just look at a weld, they can feel it, they can see it in different spectrums of light, they can even listen to it with a precision that no human could ever hope to match. So how in a world does it do that? This is how. You've got thermal cameras watching the exact temperature of the molten metal, millisecond by millisecond. You've got computer vision analyzing the shape and consistency of the weld bead. Force and torque sensors are literally feeling the physical stress of the process. And get this, acoustic sensors can hear the tiny, inaudible signals that tell you there's a flaw hiding inside. It's basically a full sensory assault on the problem. And this diagram right here, this is the heart of the challenge. This isn't about just spotting a simple crack on the surface. No, it's about understanding the deep, complex physics of what is happening inside that metal. You've got dozens of inputs over here on the left, the specific alloy, the shape of the parts, the heat, the speed, and they're all interacting in crazy ways to create the final weld properties on the right. This is exactly what we mean when we say a materials-aware AI. It has to understand the metallurgy, the actual science, to predict the final quality. Okay, so collecting all that sensory data is just step one, right? The real magic happens when you teach an algorithm what it all means. This is where we essentially take decades of metallurgical science and hard-won engineering experience and encode it all into a machine learning model. So let's walk through the basic idea here. First, you acquire an image. That's your camera. Next, you have to process it, cleaning up all the visual noise you get from such an intense environment. And then finally, that clean data gets handed off to the AI algorithm, which has been trained to pinpoint and classify any problems it sees. Let's break that AI algorithm part down a bit more, because this is cool. Think of it like training a master apprentice, but at lightning speed. First, you just dump data on it, thousands of examples of both perfect welds and all kinds of flawed ones. Then, during training, the model just pores over these examples, learning to connect these incredibly subtle patterns, a tiny dip in temperature, a specific vibration, to a particular defect. It's learning cause and effect at a microscopic level. You give it a final exam with validation data, and if it passes, boom, it's ready for the factory floor. Now, this is where it gets really clever. The best models out there use a kind of hybrid approach. You've got the CNN part, think of that as the eyes of the system. It's amazing at analyzing the spatial info in an image, the shape of the weld. But then you have the LSTM part. That's like the brain's memory. It analyzes the data over time, understanding the dynamics of the whole process. So it's not just about what the weld looks like in a snapshot, but how it's behaving from one moment to the next. And believe me, the technology here is moving at a breakneck pace. Just look at this chart showing the evolution. We've gone from these early, simpler concepts to incredibly sophisticated networks, like something called a faster RCNN, which can not only tell you that there's a defect, but can draw a box around its exact location in the image, all with just unbelievable speed. Okay, so that's all the cool theory, but what does this actually look like in a real factory? What are the tangible bottom-line results when you put this tech on the shop floor? How's this for a result? Some of these deep neural networks, just by listening to the force data, can hit over 95% accuracy in detecting internal weld defects smaller than 1/10 of a millimeter.
I mean, that is an absolutely insane level of precision.
And that precision, well, it leads to a whole cascade of benefits. We're talking about catching defects the very instant they form, and even better, having the system adjust the welding robot on the fly to fix the problem before it gets worse. That means less waste, higher quality, and the ability to truly guarantee that 100% of your product is perfect. It can even predict when the machine itself is about to fail, preventing costly shutdowns. And a really key piece of this puzzle is something called Edge AI. This just means the heavy-duty processing doesn't happen in some faraway data center in the cloud. The intelligence is right there, on the machine, on the shop floor. That's what makes that instant, real-time feedback and control possible. No lag, no delay, just immediate action.
So where is all this headed? It's really easy to see this as, the machines are taking over, but the reality is actually way more interesting. This is all about creating an incredibly powerful new toolkit for human experts.
And this is the main takeaway, the thing to really remember. AI is not replacing the welding engineer. What it's doing is giving them superpowers. It's taking all their deep knowledge, all their expertise, and it's scaling it. It's allowing them to apply that human insight to every single weld coming off the line, something that was just physically impossible for any one person to do before. I mean, this whole transformation of welding is just a perfect example of AI augmenting human skill to reach a completely new level of quality and efficiency. It really gets you thinking, doesn't it? Now that we've given machines superhuman senses for welding, what other age-old industrial craft is going to be the next to get a 21st century upgrade